So hello dear, today we are going to solve physics unit 4 and you can see the dates and paper code here. Okay, let me come on section A. So see, section A, the first question is oxygen 817 means oxygen, this oxygen is an isotope of oxygen. Okay, and oxygen, as we know, oxygen has two isotopes. One is 8 and 16 and the second one is 8 and 17. Okay, so which row of table gives the number of nucleons and number of neutrons in an atom of oxygen 817? So what is number of nucleons? Number of nucleons is same as the mass number, and as we know, the mass number is protons plus neutrons, and proton is equal to number of electrons. So, and this electron number is same as the atomic number. So here the H represent as atomic number, or you can say it as a proton or number of electrons. So here we can say 17 is equal to number of protons means 8 plus n number of neutrons. So 17 minus 8 is 9, so number of neutrons will be 9, and number of nucleons is the same as 7. Proton plus neutron, that is mass number, and mass number here is 17. So you can finally answer will be D. Okay, the question number 2, which row in table gives the charge and mass of an antiproton? So antiproton is as equal as electron. Proton means positive charge. Okay, positive charge, and electrons has negative charge. Okay, and mass of electron is, as we know, 1.67 into 10 is to minus 27 kg, or and the charge will be negative. So you can say here this mass is for proton and this mass is for electron. So, and mass can't be in negative, so this option B. Okay, this is mass of proton and this is mass of electron, and here we are talking about antiproton, therefore it is mass of electron and charge of electron. So this will be the correct answer is D. Now the fourth question, 3 and 4 refers to a collision between two trolleys. The diagram shows the momentum of two trolleys X and Y before a collision. The mass of each trolley is this. So this mass of this trolley X is 0.25 and this one is also 0.25. Okay, and this X trolley is pulled by a force of 0.5 and this is at rest. So as we know, there is no external force, so the momentum will be conserved. P initial will be is equal to P final. Okay, the momentum initial is equal to momentum final. So two trolley joins together after the collision and moves on with a velocity of 1 meter per second. So here we before collision the momentum will be momentum, so mass into velocity, and this one is 0, so because velocity is 0, and here the mass x m plus m, same masses, and the velocity is 1. So here 2m and m is equal to 0.25, and here you can say this m is equal to 0.25 multiplies v. So the v will be 2 meter per second. So initially the x moves with 2 meter per second. Okay, and after collision it moves with half, yani 1 meter per second. Which of the following is kinetic energy of trolley X? So which of the following before the collision? So X is moving with 2 meter per second and its mass is 0.25. So we can use here the kinetic energy formula, half m v square. So half m is 0.25, mass is 0.25 and velocity is 2 whole square. So here it will be 4 divided by 2, it will be 2 and 2 multiplied by this. So you can say this is 0.25 joules. So from here the correct answer would be A. And now which row of table is correct for this collision? Okay, so momentum is conserved, not conserved, not conserved. So as we know, there is no external force, means the option C and D can't, will be wrong. This will be wrong, this will be wrong. Either this can be right or either this can be right. Now the elastic or inelastic collision, which one is this, elastic or inelastic? So as we know, in elastic collision there is no loss of kinetic energy, and in elastic collision there is a loss of kinetic energy. So before the collision the kinetic energy was this 0.5, and after the collision we have to solve. After the collision this one is moving, so half m, now the m is 0.25 twice because there is mass of x plus mass of y. So we will write here the mass of 0.25 multiplies 1 whole square. So this will be 0.25 joules. The final kinetic energy is 0.25 joules. So there is a loss of kinetic energy of 0.25. So therefore this is an elastic collision and momentum is conserved. So the question fourth answer is B. Now fifth question. Question fifth and sixth refers to a cathode ray tube. The diagram shows some of the component in a cathode ray tubes. Okay, this is a metal of heated metal filaments. Yeah, when this filament will heat, some electrons will ejected. Okay, the path of electron. This is the path of electron, and this is parallel metal plates. And here we have a screen where the electron will deflect or not. So electrons are released from the heated metal filament. Which of the following name of this process? So this process name, so you can see here which of the following is the same of is the name of this process. So this is not the ionization, because ionization just of electrons released there from the outer electrons. This is electric emission. No, photoelectric effect is done by the effects of light. When light fall on the metal surface, then electrons eject. Relativistic effect, no, this is a thermic, because this electron is removing by the heat of, okay, by heating, because this filament is heated, so some electrons ejected. So this process name is thermionic emission. So fifth will be D. Now when a potential difference is applied across the parallel metal plates, the electrons are deflected. Okay, so when some potential difference, you can see here, this is a parallel plate, is applied across the parallel plates. When we applied some potential difference, the electrons are deflected. Okay, which of the following changes could decrease the deflection of electrons? So by applying a potential difference, okay, potential difference across the plates, so what will happen here? As we know, force formula is Q times electric field, and electric field formula as electric field is equal to voltage divided by D. So here you can substitute E as, so finally F will be equal to Q V divides by D, or as the distance between the plates will increases, the force value will decrease. So electron, when this parallel plates have some potential difference, electron feel some forces, or as we reduce the D, okay, as we increase the value of D, the distance between the two parallel plates, F value will be decreased. So when F will decrease, so deflection between a deflection of electron will also decrease. So here you can say the decrease the deflection of electron by increasing the distance between the plates. So question 6, correct answer is D. Now question 7th. A square coil PQRS has sides of length L. Okay, sides of length L. There is a clockwise current I in the coil as shown. So this clockwise I current is flowing in this coil. The plane of the coil is parallel to the magnetic field. Okay, this coil and the magnetic field are parallel to this magnetic field. Magnetic field of flux, magnetic flux density B. Which row of the table is correct? So which row of the table is correct? The side of coil PQ. The side of coil PQ, magnetic force is 0, and QR and RS and SP. Which one is correct? So as we know, the force formula BIL sine theta, and this theta, and this is the angle between, okay, the angle between this length, the direction in which the current is moving, so PQ, and the magnetic field. Okay, so it's an angle between the length and magnetic field. So here in case of PQ, you can see here, in case of PQ, the PQ direction and the magnetic field direction is parallel, so the angle will be 0. So in that case, the force will be 0 in PQ, and here you can see PQ and force is 0. But in case of QR, it's perpendicular, theta is 90, and it cannot be 0. So this is wrong. In RS case, R and S, again it's anti-parallel because the direction of R and S, the direction is this. So the theta value is 180. Okay, why 180? Because this is in this direction and the magnetic field is the right direction, and RS in the left direction, so the angle will be 180 degrees. And in case of SP, the theta value is 90 degrees, so it will be 0. So only option A is correct, so correct answer is A. Now question 8. In the early 20th century, experiments were carried out to measure the scattering of alpha particles after striking a thin gold foil. Which of the following could not be concluded from the results of these experiments? So this experiment, the alpha scattering particle done in 1911, or when this experiment has done, so what was that? The alpha particle, it concluded that the nucleus is charged. Okay, it placed in the center of the atom, and nucleus contains most of the mass because it is the heaviest part here, and apart around the nucleus there is a most empty places. Okay, these were empty, there was no sign of having any charge or other particles. So around the nucleus, he concluded that it is empty, almost empty, and the D is the nucleus is very small compared to the atom. This was also right because if the atom is this much big, so the nucleus is only about only this much size. So This option C is the nucleus contains neutrons and protons. This was discovered by Rutherford in 1917. So you can say here this was not uh, concluded from the result of this experiment because it was done later. Okay, so 8 is option C. Now question 9. A charged particle is accelerated in a spiral path in a cyclotron. Spiral path है this is spiral path and this is this. Which of the following changes would increase amount of energy transferred to the particle as it travels through 360 degrees? It starts from here and there, and it will make a spiral path on the disc. So increase the distance between the disc, increase the frequency of potential difference across the disc, increase the strength of magnetic field within the disk, or increase the maximum potential difference across the disk. We know the formula. The kinetic energy can be written as Q times V. So if we increase this voltage, so overall the kinetic energy will increase. So increase the maximum potential difference across the disks. So overall we will increase the potential difference. So finally kinetic energy will increase, and by the increase of kinetic energy, increase the amount of energy transferred to the particle as it travels through 360 degrees. Now the question 10th, a website states the radius of orbital of moon around the earth is increasing by a small amount each year. However, the time period of orbit remains constant. Okay, so as let's say if the distance between moon and earth is this much, so every year it is increasing by small distance from here to, let's say, it increased by this much. But it is saying the time period of orbit remains constant. Which row of the table is correct if the statement is true? The angular speed of moon, constant. The angular speed means in the same time it travels like the same angle. Okay, so this and this. So here we can say it is angular speed must be same, must be constant. So angular speed must be constant, but the speed of moon will increase. So yes, speed of moon will increase because angular speed formula is omega is equal to, okay, omega is equal to v by r. So if this is constant and this is increasing, here we can say omega times r. Omega is constant and the radius is increasing. Okay, the radius is increasing, therefore so the velocity will also increase. So here we can say moon velocity will increase. The option D is correct. Now section A is complete. Now section B. The diagram represents a negative point charge. So negative point charge, draw field line to show the electric field around the charge. So negative charge fields is towards itself, and positive charge electric fields are outward. Because if the positive charge is there, so the electric field will be outward, and if it's a negative charge, so electric field lines will be inwards. So it will be inward. Now a helicopter can hover in a fixed position as shown. This is helicopter blades here. This is helicopter blades, and the helicopter blades moves air vertically downward. Explain how this enable the helicopter to maintain a constant height above the ground. Because the blades of helicopter exert a downward force on the air. Okay, the air exert an equal force in upward on the helicopter by the Newton's third law of motion, and there is an equal upward force. This force in upward should be equal to the weight of helicopter. The resultant force is zero. So by Newton's first law and second law, there is no acceleration, and the helicopter remains at constant height. Now, the surface of a balloon can become charged by rubbing it against clothing. Okay, this is done by the transfer of some charge, which is called as induced charge. The charge on the surface of balloon can be assumed to act as if it was concentrated at balloon's center. Two balloons are suspended by a cotton thread so that they just touches each other as shown in figure 1. The two balloons then are given an equal negative charge and ripple as shown in figure 2. The dots represent center of each balloon. Okay, these dots represent the center of each balloon, and here the distance between these center of these two balloons is 0.21 meters, and the length of this is 1.22 meters. So length of this 1.22 meters, and after giving the same charges negative on both sides, so as we know, the same charge repels each other and opposite charge attract each other. So here what we can say, the diagram is the difference between these two centers after repulsion is, already it was at 0.2 meter per second, and after of negative charge or because of repulsion, the difference between these two balloons increases, and it becomes 0.47. so the actual difference by the forces is 0.47 minus 0.1 or 0.21, so it is 0.26. Okay, so if we use a Pythagoras theorem here, so this length we know this length, this is 1.22 meters, and we know this length also, and this length is half of this, so this is 0.13 meters, and we can find here the value of theta. So the value of theta is cos theta 0.13, and this is 0.22 meters. But what we have to show that the force of repulsion between the balloon in diagram 2 is about this, and mass of each balloon is this. So repulsion force we have to show here. So make a diagram. Let's suppose a diagram is like this. This is center of balloon, and here it's mg. Here the force is because of charges, so electric force is here, and this is the tangent, this is theta. So this force will be breakdown in two form, t cos theta and t sin theta. Okay, t cos theta and t sin theta. The force will be this. So from here we can say the mg is equal to this, and the force of electric force is equal to t cos theta. So we can take here uh, the tangent of it, okay, the division of this, and so finally we can solve here by the relations. This sine theta is this, and it comes 6.12 degrees, and t cos theta is equal to mg, and t cos theta values, and we will find the t, the tangent values. So after the calculation we can substitute. The mass value of electron is 1 point what is it, the mass of balloon. Okay, the mass of balloon is given here 1.1 gram. So 1.1 gram in kg, and the value of g in Newton per kg meter, Newton per kg. And after calculation we get tangent as this. Okay, tangent at this is final. It was -3. So the tangent is this. Now t sine theta, because uh, t sine theta, okay, we have solved t cos theta. Okay, you can take the angle theta this also, but the calculation I have done here, it is taking the theta this, the vertical theta. So we can change it, but you can solve by using this as a theta, and you can solve further. It won't change anything, but the calculation I have done by taking this as theta. Now everything is right. So now this will just change as because I take this as theta, so now by angle, opposite angle, now this will become theta. So now this time t cos theta will be up, t cos theta, and this will be as t sin theta. So here the t sin theta is equal to force of repulsion, and t sin 6.12 degrees, and t value is 10.9 into 10 raised to minus 3 newtons, and multiplies this. So the force of repulsion is about 1.16, and this, and it is equal to almost about 1.1 into 10 raised to minus 3 newtons. So you have done here. Now the second part, show that charge on each balloon is about this much. So the charge is, formula is k q1 q2 upon r square, and the value of k is 1 upon 4 pi epsilon naught. So here the repulsion force is equal to q1 upon q2, and this is because the q1 and q2 is same, because in question is given at the charges are equal. So q1 and q2 are same, so here it will become kq square upon r, and this is the value of 1 upon 4 pi epsilon, value is 8.99 into 10 raised to plus 9 Newton meter square per coulomb square. So this is the value of k, and it's q square, and the radius is given, the center, this r is the distance between 2 point charges. So 2 point charges is this, because this is a point and this is a point. So point charges, so distance will be this, and after calculation we got q as 1.69 into 10 raised to minus 7 coulombs. Now b, one balloon is removed and remaining balloon returns to its original position. Calculate the electric potential at a distance of 0.3 meters from the center of the remaining balloon. So as we know, the potential electric potential formula at some distance, V is equal to kq upon r, kq upon r. So V is equal to, we will substitute k values here, and q, as we have solved here the value of q here, so we will substitute the value of q and the distance of 0.3 meters. So after calculation we got the potential difference. Let's suppose this is a balloon, and after 0.3 meters the potential here is 5.064 into 10 raised to minus 10 raised to 10 raised to plus 3 10 raised to plus 3 Newton meter per coulombs. Okay. Now question 14. A student built the current circuit shown. A student built the circuit shown. The capacitor was initially uncharged. The capacitor was initially uncharged. She closed the switch and plotted a graph of current on ammeter 1 against time. So at t is equal to 0, at the time in seconds, so when the switch is started the current was 0.15 milliampere, and after 30 seconds the current become here 0. Okay, so current becomes 0. Determine whether the initial value of current on the graph is consistent with the values started on the circuit diagram. So we will use here the Ohm's law. Ohm's law says V is equal to IR, V is equal to I and R. So voltage is given and resistance is also given. So current will be 5 divided by 33 into 10 raised to 3, and after calculation it will be 0.5 milliampere. So it is consistent, it is matching. Okay, so according to Ohm's law, I is equal to V by R. Current is equal to this, and after calculation we get I as this. Explain how the current on ammeter 2 would vary over the same time. The current would vary same as the flow in ammeter 1. The flow is same everywhere in the series circuit. Now determine the capacitance of the capacitor. So as we know the formula, this is the formula of I is equal to I naught e raised to t minus t upon ER. This is the resistance and this is the capacitance. Takes ln both side. Okay, so I have taken the ln. Ln means the log with base e, so we can take ln. Ln I is equal to ln I naught, and this power will come down, so minus e upon RC, and ln e value is 1, so I didn't wrote here. Okay, so the current value is 0.01, minus initial sorry final current is almost 0.01 current, and initially it was this it was this, and it is equal to minus T by RC. So after calculation we got here this, and at 20 pay, this is at 20, time is 20 seconds, the current value is this 0.01 milliampere. So I have substituted here the current at 20 seconds, and initial current was this 0.15, and after calculation we got here plus 2.71 is equal to plus 20 divided by 33 into 10 raised to 3 coulombs. So 1 upon C is equal to this, and after calculation we got here the capacitance is 0.23. Okay, when we will take the reverse of reciprocal of these values, so it will be C, and this 20 will go up and it will this, and after calculation the capacitance is 2.23 into 10 raised to minus 4 Fahrenheit. Now determine the charge stored on capacitor after 30 seconds. So after 30 seconds, how much charge will be stored? So after 30 seconds, capacitor will be fully charged, and the circuit will become open circuit. Okay. When this capacitor will be fully charged, it will break. No current will pass through. So it will behave like an open circuit. So Q is equal to CV. Q and C is equal to, and we have calculated 0.2.23 into 10 is to minus 4 multiplies the voltage is 5. Okay, and it will be the charge after 30 seconds stored on capacitor is 1.11 into 10 is to minus 3 coulombs. Now E, determine the maximum energy stored by the capacitor. So maximum energy stored is equal to half CV square. So half, the value of C is 2.23 into 10 raised to minus 4 Fahrenheit multiplies 5 whole square and divided by 2. So after calculation we got the maximum energy stored by capacitance is 27.87, okay, 27.87 into 10 raised to minus 4 joules, and this is the maximum energy stored by a capacitor. Okay, so we have done here. Thank you for watching video.